get this over with. 1, 2, 3, 4.
This is a Bowler educational production brought to you by our following sponsors.
National Science Foundation, where discoveries begin. Northrop Grumman Corporation. Ernst & Young, quality in everything we do.
Presenting 20th Century Fox. Welcome to the Big Solution Show, where I, Steve the Frog, and my best assistant, Daisy the Duck, will teach you guys all about solutions. We can't wait to have fun with you when we learn about the definition of solutions, the types of solutions, solubility and rates, saturation, and electrolytes. See you in a few seconds. Okay guys, to first define solutions, we must know the difference between a solute and a solvent. A solute is whatever dissolves in your solvent. For example, salt. Salt dissolves in water, which water would be your solvent in this case, while salt would be your solute. The solvent is whatever dissolves the substance of the solute, in this case, salt. So, now that you know the difference between a solute and a solvent, we will now discuss the definition of solutions. But according to Google, a solution is a liquid mixture in which the minor component, or the solute, is uniformly distributed within the major component, the solvent. Basically, for you kids to understand, a solution is a homogeneous mixture. Homogeneous mixture is one that's evenly blended. So a solution is a homogeneous mixture that contains a solvent and a solute, where the solute is able to be dissolved by the solvent. And all this defines the solubility of the solute, which means the tendency for that particular solute to dissolve in a solvent. Okay, so now me, Steve the Frog, and my assistant, Daisy the Duck, will show you guys pictures of us with different types of solutions. There are many different types of solutions, all constituting from the three states of matter, primarily from liquids, solids, and gases. So, let's begin with a solid in gas solution. A solid in gas solution would be snow. As you can see, me and my friend Daisy are playing in the snow. Snow is a solid in gas solution because of the crystallization process that takes place on forming solid crystals, which is the snow, and what happens is that those solid crystals precipitate from a solution that involves a solid and gas. What happens with this gas? What is this gas? Well, this gas would be the various water molecules that have evaporated, so basically water vapor, since it's a gas form of water, that crystallize to form a precipitate of snow. So this defines a snow in gas solution. Yes, I know my voice got a little deeper, but that's because I matured within these few seconds. But because that took longer than we thought it would take, we will now discuss the following types of solutions a little bit more quicker.
So the next solution would be a gas in gas solution, and an example of that would be air, since air is a homogeneous mixture of various gases like carbon dioxide, oxygen, and many other gases. Okay, so now a solid in liquid solution would be seawater, since the solid, which is salt, NaCl, is dissolved in the liquid, H2O, water, in an ocean. So an ocean would be an example of a solid in liquid solution. An example of a solid in solid solution would be a trumpet, since a trumpet is primarily made of brass, and brass is a homogeneous mixture of various metals like zinc and copper. So those metals are homogeneously mixed into a solution of brass, which is a solid in solid solution. An example of a gas in liquid solution would be a Coke or a Dr. Pepper of some sort, since the gas, when creating the Dr. Pepper, is pressurized into the liquid, which is the actual part you drink out of the specific soda. An example of a gas in solid solution is concrete, since there is various gases from cars whenever they pollute the environment with their steam, with their engines and all the pollutants coming out of the back pipe of a car. Those gases can slip through the bubbles found in concrete, and that's why it's a gas in solid solution, since the gas goes into the little pockets of air found within concrete pores or something like that. An example of a liquid in liquid solution would be vinegar, since vinegar is made out of acetic acid and water. Those two blend together homogeneously to make vinegar. An example of a liquid in gas solution would be sparkling cider, since the liquid, which is the actual cider itself, is placed inside the gas carbon dioxide to make the sparkling cider pop. Whenever you're gonna drink some in, for example, New Year's Eve or New Year's Day, that's what gives it the extra pop of your wine bottle. Finally, an example of a liquid in solid solution would be quicksand, since the liquid, which is the water, goes into the solid, which is dirt, mud, soil, a bunch of eroded minerals and materials that constitute or form the basis of mud. So yeah, those are all the types of solutions. Next we will discuss solubility, where we will refresh on solubility and discuss the different rates of solubility of different types of compounds.
Remember I said that we were going to show pictures of me and Daisy with different types of solutions? Well, now we're bringing that back, and we're going to show you those different pictures with us in them. And because I talked a lot in the previous episodes, the previous scenes, I will now not talk, and we will just show a little song, okay? Enjoy! To discuss solubility and rates, and I'm Daisy the Duck because Steve the Frog is on vacation right now, so I will take over. So solubility is the maximum amount of a solute which can dissolve in 100 grams of solvent at a fixed temperature. For example, if you have 200 grams of salt, that would be your maximum amount of solute that can dissolve in 100 grams of water, which is your solvent, at a fixed temperature, which could be 30 degrees Celsius. Factors that affect the solubility of the solute, thus decreasing or increasing the rates of solubility, will be the nature of the solute, which depends on the physical and chemical characteristics of the particular solute, the nature of the solvent, which is basically affects the same thing, and the temperature of the solution. For solids, if the temperature is increased, then the solubility of solids and liquids will increase.
For a gas, if the temperature decreases, then the solubility will increase. Thus, the solubility of a gas will decrease if temperature increases. So it's like opposites. The rate of dissolving is the time taken for a particular solute to completely dissolve when it is added to a fixed amount of solvent. So, factors that affect the rate of dissolving of the solute would be the surface area of the solute and the temperature of the solute. So surface area, many people associate having more of a substance or like a more compact form of a substance to be a higher surface area, but in actuality, a compact solid like a sugar cube has less surface area than one that is crushed. Thus, a greater surface area would be a crushed solute. And that would increase the rate of dissolving because that would dissolve faster in water or any other solvent. So, and then increasing the temperature, of course, also increases the rate of dissolving. Ways to apply this to real-world situations would be at home, because a washing machine uses hot water and a rotating drum to increase the solubility and rate of dissolving of detergent in water. So what is meant by this is that a washing machine heats itself up and rotates itself in order to get every particular inch of clothing and to be able to use dissolved detergent in water to clean and wash your clothes. So that's an application you could associate with solubility and rates of dissolving. I hope that was helpful. Sorry about that jump scare, but that happy face just made me want to put it there and make it at the right moment, because I just want to make sure you're still awake so we could discuss saturation. Saturation is, or the state of being saturated, is whenever a solution has a solute that will no longer or no more dissolve in a solvent. So basically, the solute can no longer dissolve in the solvent. There's enough solute in that particular solvent that it just cannot uptake any more solutes. The alternative to this would be an unsaturated solution, and what that means is that the solvent can still uptake more solute, and it hasn't fully met its state of saturation. On the contrary, a supersaturated solution is one where there is more than enough solute present in the solvent, and even extra solute will sink to the bottom because the solvent cannot dissolve that solute anymore, and there's more than enough past saturation. So, different examples that could be given for saturations. A saturated solution could be, for example, a Coke or a Dr. Pepper, because they have enough sugar. An unsaturated solution could be, for example, you take water and you put Kool-Aid in it. And well, it's not completely saturated because there could be more sugar in that particular Kool-Aid. But you don't want to get diabetes because of all the sugar, so you put just a little bit. And supersaturated solution could be like a sugar overload inside water. You just take all the sugar in the world and burst it in a glass of water. And that is supersaturated because a little glass of water is unable to take up a whole gallon of sugar.
Everywhere you look and everywhere you go, sugar, sugar, sugar from your head to your toe. When you've eaten lots of sugar and you've had too much, watch out everybody, it's a sugar rush. Watch out everybody, it's a sugar rush.
Okay, for the last part of our presentation, we will discuss electrolytes. An electrolyte is a substance whose aqueous solutions conduct electricity. It forms ions in an aqueous solution. An aqueous solution is basically anything that has been dissolved in water. But in simpler terms, an electrolyte is an ionic compound that conducts electricity in water. What this means is that an electrolyte is basically anything that's conductive and allows electrical currents to pass through its ions. On the opposite of this is a non-electrolyte, which is a substance whose aqueous solutions do not conduct electricity. And a non-electrolyte does not form ions in an aqueous solution. So, what two things make a compound an electrolyte? Well, first it has to be ionic, and with that it has to have positive and negative charges to its ions. It also has to be soluble, or able to be dissolved in water. The main thing to know is that salt is ionic while sugar is not. Although sugar is soluble, it is not ionic. Thus, it is not an electrolyte. A cool thing to know is that if you place electrical rods at the inside a beaker with electrolytes present, it will be able to power a light bulb if a battery is present. So it could complete a circuit, and that's what's important about electrolytes, that who knows, maybe if the power's out and you have a portable battery and a light bulb and nothing but like salt and water, you can make your own electrical light, and wouldn't that be cool? So this is the end of electrolytes, and now we will go to our credits. Sadly, we are done with our presentation. I hope you liked it. But it's good to honor those who made this presentation and all the effort that went into it. So, goodbye!